Good morning everybody, myself Acharya Vishvendra, and today I'm going to discuss a worksheet on Ohm's law. So let's begin with the worksheet. So here is the first question that Ohm's law is. So Ohm's law states that V proportional to I or V is equals to IR. But its real physical significance is that voltage across a ohmic resistor is directly proportional to the current. So that is analysis of this law. Second is a graph between V and I. So obviously V is proportional to I. So the graph will be a straight line, and tan theta here will be V by I, which is equal to R. It is important to note that Ohm's law is significant in the sense that it states that for certain specific, you can say, resistors or conductors which are called as ohmic resistors or ohmic conductors within certain limit, the graph between V and I, that is voltage and current, is a straight line. So that is the real physical significance of Ohm's law. In the next question, we have VI graph for three different cases. So as we have derived over here that tan theta is equals to the resistance. So theta 3 is greater than theta 2 is greater than theta 1. That means resistance corresponding to third graph will be greater than that of second, will be greater than that of first. And next question is maximum resistance is shown obviously by 3, minimum resistance by 1. Next question is arrange resistances in ascending order. Ascending means increasing order. So obviously R1 is least and R3 is greatest. So the order will be R1 less than R2 less than R3. The next question is arrange resistances in descending order. That means decreasing order. So the order will be R3 greater than R2 greater than R1. Now moving to the next question, question number 7, that is maximum conductance is shown by. Now resistance is inversely related to conductance. So minimum resistance means maximum conductance. Resistance is minimum for 1, so conductance is maximum for 1. Then is minimum conductance is shown by. So minimum conductance means maximum resistance, which is shown by graph 3. So 3 will be the answer over here. Next we have a question that a cylinder of length L and radius R is given, cross section area is A, and current is moving like this from left to the right. So this is the cross section area for passing of the charge through the cylinder. So the first question here is resistance is given by. So resistance is rho L divided by A. Rho is the resistivity, L is the length, area is the cross section. So one function will be this. Another function is that area can be written as pi r square. So resistance will be rho L by pi r square. Next is on what factors resistance depends. So resistance depends on temperature, nature, size and shape of the conductor. Next is on what factors resistivity depends. Resistivity depends only on nature and temperature, but is independent of shape and size. The next question, we have a material has resistance R at temperature T1, temperature coefficient is alpha. Then we need to find resistance at T2. So using the expression, we have R2 is equals to R1, 1 plus alpha T2 minus T1. R1 is the initial resistance. Then in the next question we are being asked change in resistance. So delta R from here we can calculate as R1 alpha T2 minus T1, and here resistance initially is R1. So this thing should be kept in mind. Then we are being asked fractional change in resistance. So this is delta R by R. So that will give us alpha into T2 minus T1. Then is percentage change in resistance. So that is fractional change into 100. So it will be alpha T2 minus T1 into 100. Now we are being given a cylindrical shell having radii R1 and R2. We need to find the effective area. So we can see that current will pass only through this section. So the effective area here will be pi into R2 square minus R1 square. Next is if we need to find resistance of this setup. Resistance will be rho L upon pi R2 square minus R1 square. Then is conductance. Conductance is inverse of resistance. So just inverse this term. We'll have pi R2 square minus R1 square by rho L. Then we have another case where the conductivity is different, K1 and K2, resistance R1, R2. And since these two are in parallel, so the equivalent resistance will be R1, R2 divided by R1 plus R2. Then conductance is 1 upon resistance. So 1 upon resistance is 1 by R1 plus 1 by R2. So conductance from here will be 1 by R1 plus 1 by R2. Then is effective thermal conductivity. So after solving it out, effective thermal conductivity is K1 plus 3K2 divided by 4. That is expression for effective thermal conductivity. So this is the worksheet, and the purpose behind designing the worksheet is that we give a number of questions based on basic concepts, basic terms, mathematical manipulations and all the relevant terms related to a particular topic, so that you have a better understanding, you have a developed neural network and you have sharp problem solving skills. So we provide you an integrated sort of working. You can cross check your preparation of the topic, and if you have any doubt you can ask in the comment section. Thank you and have a nice day.